Today's lesson is about dividing rational numbers. Rational numbers include integers, decimals, and fractions, and that includes them going in the positive and the negative direction. So before we kind of dive into actually dividing rational numbers and learning the rules, it's important to kind of review what are different symbols that can be used for division, as well as some of the vocabulary terms associated with a division number sentence. So for example, the division symbol is one way that we can write a division number sentence, and that just looks like this: A divided by B, where B cannot equal 0. So we have kind of our traditional division symbol. We can also do A divided by B using a fraction bar as division. And again, B cannot equal 0. Using fraction bars as division is definitely a very common way you'll kind of see it moving forward in your math career. So now let's look at the definitions associated with a division number sentence. So let's give an example like 6 divided by 2 equals 3. So 6 divided by 2 equals 3. 6 would be the number being divided by, and that is what we call the dividend. 2 is the number that we're dividing by, or how many groups we want. So we have 6 things, we want 2 groups of them. That is called our divisor. And then the answer to the division problem is 3, and that is called our quotient. And that essentially is how many things are in each of those 2 groups. So if I have 6 things and I divide it by 2, I'm going to have 3 things in each of those 2 groups. So let's look at our rules for dividing rational numbers. So our rules for dividing rational numbers are actually the same as multiplying rational numbers. And that is a way that we can kind of use fact families to prove it. But for today's lesson, we're just kind of going to go through those rules. So the first rule is dividing 2 numbers with the same signs, the quotient will be positive. So what that looks like is if I have 1 divided by 1, that's going to give me a positive 1. Or if I have negative 1 divided by negative 1, that would also give me a positive 1 as my answer. So that's what it looks like using a fraction bar. Either my numerator and denominator are positive, or my numerator and my denominator are negative. If I'm looking at it using the traditional division symbol, 1 divided by 1 equals 1, or negative 1 divided by negative 1 equals positive 1. So either way, both my numbers need to be negative or both need to be positive in order for my quotient to also be positive. Now, my second rule is if I divide 2 numbers with different signs, the quotient will be negative. So one way to kind of look at that is if I have 1 divided by negative 1, my quotient will be negative 1. Or if I have negative 1 divided by positive 1, my quotient will also be negative 1. So using division symbols, that's kind of where the negative sign would go. One's positive, one's negative. Now, if I'm using a fraction bar, it's important to understand that your negative 1 can only appear in the numerator or the denominator. So for example, negative 1 divided by 1. Or I can have that negative 1 in my denominator and my negative in my numerator. Sorry, and my negative number in my denominator and a positive 1 in my numerator. Either way, that's going to give me a quotient of negative 1. What we don't want is we don't want a negative in my numerator and denominator, because that actually would be a negative divided by a negative, which actually would give us a positive quotient. So it's really important to understand that when you are dividing 2 numbers with different signs, that negative can only be assigned to the top or the bottom, the numerator or the denominator. We've also seen negative kind of fractions with the negative on the outside of a fraction. And that would also still give us a quotient of negative 1 if that negative is kind of denoting the whole thing being negative. So where you put your negatives is actually really important in understanding if that's a negative fraction, if that's a negative in my numerator or in my denominator, or both. So where that negative falls again is really important, especially as you move forward in math class. So now we're going to look at some practice problems. So when we go to divide rational numbers, we kind of just divide as normal. The only thing that's going to be different is determining if your sign is going to be positive or negative. One strategy I've used is I like to kind of categorize my questions as, same signs or different signs. So kind of taking it rule by rule. sometimes helps when you're just learning. So I'm going to go ahead and take a minute and I'm going to circle all the problems that have the same signs, meaning I'm dividing two positives or two negatives. And then I'm going to go back and I'm going to go ahead and circle all the problems that have different signs, meaning one number is positive and one number is negative. That's helped me make sure that I know if my answer is going to be positive or negative. So all of the questions that have a pink circle around them means that my answer should be positive because they are the same signs. If my question is purple, that means they have different signs, meaning my quotient should be negative. So if I just go ahead and do the same signs, I'm going to start with question 3, and I'm going to go -8 divided by -1 would be +8. Jumping over to 6, I have -36 divided by -9, that would be +4. -63 divided by -7 would be +9. And then number 10 would be -30 divided by -15 would be +2. Now going back to the purple ones, my different signs, all those quotients should be negative. So 120 divided by -12 should be -10. -30 divided by 5 is -6. 84 divided by -7 should be -12. -132 divided by 11 should also be -12. Number 8, 48 divided by -6 should be -8. And then -12 divided by +12 is -1. So again, we're dividing as normal, but we're just thinking about is our quotients going to be positive or negative depending on the sign. So we're going to jump down to decimals and fractions. And when we do decimals, when we're dividing, we want that second number, our divisor. We want our divisor to be a whole number. So in this case, 3 is a whole number. Now, the way you want to divide this is there's a lot of different ways. I'm going to kind of just go traditional, where my dividend goes in the inside and my divisor goes in the outside. So this is 2.4, and then I'm going to follow my decimals straight up. And so I'm looking at 3 goes into 24 8 times. 8 times 3 would be 24, and I wouldn't have any kind of remainders there. So my answer would be 0.8 or 8/10. But if I look back at my original problem, I have a negative divided by a positive, so my answer should actually be -0.8. So if I look over at number 12, I have -8 divided by -1.5. You can also rewrite it like this if it helps. Either way, I want my divisor to be a whole number. So a way I can do that is I can multiply both my dividend and my divisor by 10. So this would become -80, and this would become -15. So when I go to set up my division problem, I'm going to show it without the negative numbers. I know negative divided by negative is going to be positive, so I'm just going to focus on essentially doing 80 divided by 15. This is essentially where my decimal would be. So I'm going to look at 15 goes into 80 instead of thinking about 1.5 goes into 8. And if I do that, I go 15 goes into 80 5 times. 5 times 15 would be 75. When I subtract, I get 5 left. I'm going to take a 0, move my 0 down. 15 goes into 50 3 times. 3 times 15 is 45. And then I'm going to start to see kind of this pattern that every time I'm adding a 0, I'm going to do 15 goes into 50, and it looks like I have a repeating decimal. So I'm going to write 5.3 with my repeating decimal line over it to show that if I continue doing this over and over again, I would keep getting 50 minus 45 with 5 left over every time. So -8 divided by -1.5 would equal 5.3 repeating. Our last two problems are about fractions. And so when we divide fractions, uh, one of the tricks is kind of keep, change, flip, meaning we keep the first fraction the same, change division to multiplication, and then we're going to flip the second fraction. And it's important to know when you're flipping this fraction, if it's a negative fraction, it's going to stay negative. We're just flipping that the numerator is going to become 6 and the denominator has become 5, where it's actually flipping the numbers, not the sign. So when I go, after I do that, there's a lot of different ways you can multiply. You can simplify kind of first, and then you can multiply across. So 11 times 1 would be 11. 2 times 5 is 10. And I have a positive times a negative, so it should be negative 11 tenths. If we want that in a mixed number, that would become negative 1 and 1 tenth. So 11 twelfths divided by negative 5 sixths would be negative 11 tenths, or negative 1 and 1 tenth. Our last example, we have a mixed number. So we're still going to do keep, change, flip, but I'm also going to, even though it says keep the first number the same, I am keeping it the same. I'm just going to convert it to convert from a mixed number to an improper fraction. So negative 1 3/4 becomes negative 7/4. Change division to multiplication, and then I'm going to flip that second fraction to become negative 6/1. When I multiply across, I get 7 times 6 is 42. 4 times 1 is 4. When I simplify that, 2 goes into my numerator and denominator. So I get 21 seconds. That can also be 10 and 1/2. So my answer could be 21 seconds or 10 and 1/2. And again, my quotient is going to be positive because I'm dividing a negative divided by a negative. So now it's your time to try the you-do problems. There's a mix of integers, decimals, and fractions again. Be sure to check with your teacher for the answers, and thanks for listening. Good luck.